Have you ever thought about the exact moment when established science just gets turned entirely on its head? I mean, we completely rely on textbooks to tell us the rules of the universe, right? From how water flows to how animals live, all the way down to the very fabric of space and time. But what actually happens when those rock-solid, established dogmas are completely shattered by new experiments? Well, in this explainer, we're going to walk through some incredibly recent, literal paradigm-shifting discoveries that are forcing scientists to basically rewrite the rules from scratch. Okay, let's dive right into this with a question that sounds deceptively simple, like what happens when a lawn sprinkler sucks water in instead of spraying it out? It sounds like a joke, right? But this is known as the Feynman sprinkler paradox. It's a problem that famously stumped the absolutely brilliant Richard Feynman and has fiercely divided the physics community for nearly a century. If it sucks water in, does it spin the same way? Does it spin in reverse? Does it just stand perfectly still? For decades, literally no one could agree on the physics of a gadget you could practically build in your own backyard. So modern researchers essentially had to look at all these historical theories, even the ones from legendary minds like Feynman, and flat out say, you guys are off. Actually, scratch that. They didn't just say it, they proved it. To actually solve this hugely divisive paradox, it required entirely new modern laboratory experiments. And I love this because it brilliantly highlights how science is a living, breathing discipline. No matter how famous the physicist is, observational reality always gets the final word. It proves that even history's greatest minds can absolutely be challenged.
So let's look at how they actually solved the century-old sprinkler paradox.
First, let's anchor ourselves with the everyday standard. We've all seen a lawn sprinkler doing its thing. Water sprays out of the nozzles, and thanks to good old Newton's third law, every action has an equal and opposite reaction, the sprinkler head gets pushed in the opposite direction, which causes it to rotate. It's simple, it's reliable, and it is completely understood classical physics.
But here is where the mystery totally throws a wrench in things. If water spraying out pushes the head the opposite way, what on earth happens when you submerge the sprinkler and force it to suck water in? Does the reverse flow pull the sprinkler head forward? The everyday assumption is, well, the whole system just simply reverses. Yet early experiments and mathematical models were incredibly inconsistent. The reverse sprinkler spun completely unexpectedly, seemingly defying the basic intuitive laws of thrust and reaction. It was a total mess.
So to finally crack it, modern researchers built a highly precise, practically frictionless reverse sprinkler in a lab just to eliminate any outside interference. Then, and this is the cool part, they didn't just watch the outside. They used specialized lasers and dyes to actually observe the internal water flow dynamics as the fluid was sucked inside. And that's how they finally pinned down the exact rotational forces. They discovered that when water is sucked in, it collides inside the central chamber in this totally chaotic way, which actually cancels out most of the rotational force. So it doesn't spin perfectly backwards. It's a completely different, much weaker force dynamic inside the chamber. Boom! Century-old problem solved.
And you know what? The sprinkler paradox is really just the beginning. Physics textbooks aren't the only ones getting a major update right now.
Let's pivot to a foundational rule in chemistry. For roughly a century, there was this photochemical dogma. It basically stated that a molecule's photochemical reactivity was directly tied to its light absorptivity. In simple terms, how much light a molecule absorbed was thought to directly dictate exactly how it would react chemically. It was a neat, perfectly logical, and totally unquestioned rule of thumb taught in chemistry classes worldwide.
But here's where it gets wild. A research team made a chance discovery that showed a seemingly completely illogical mismatch. They found specific organic molecules that were highly reactive to light despite barely absorbing it at all. This directly contradicted that 100-year-old dogma. And it wasn't an easy win. It took a grueling 10-year struggle for this team to get their results taken seriously by the community. It just goes to show it's incredibly hard to overturn an established scientific rule even when you have the undeniable data sitting right in front of you.
Now, moving from the chemistry lab to the great outdoors, biological dogmas are falling just as fast. Take a look at some of these recent observations that are just busting nature's myths left and right. For years, we've repeated the fact that spider silk is vastly stronger than steel, but deeper material analysis is bringing some highly nuanced caveats to that legendary claim, revealing that its strength actually plummets the second it's exposed to excess moisture. Or take the ocean. Researchers recently documented high-speed orcas literally blowing giant sunfish to absolute smithereens. I mean, that showcases predatory behaviors we previously thought were totally impossible for the species. And then there is the incredible mathematics of mammalian life.
Which brings us to one of the most fascinating biological limits in existence: 1 billion. Modern researchers have highlighted a really strange mathematical consistency across the animal kingdom.
Virtually every single mammal gets roughly 1 billion heartbeats in their lifetime. Think about it. A mouse has a racing, frantic heartbeat and lives for a very short time. A whale's heart beats incredibly slowly, and it lives for decades. But the total heartbeat budget across all these different species remarkably zeroes in on this 1 billion mark. It's this profound, hidden rule of biology that we are honestly just now fully appreciating.
All right, now we're going to shift our focus to the absolute extremes of experimental research.
Central to this is Hawking radiation. The legendary Stephen Hawking proposed this highly elusive theory that black holes aren't actually completely black. Because of complex quantum effects near the edge, what we call the event horizon, they should actually emit tiny, tiny amounts of thermal radiation. The problem, though? This radiation is so incredibly faint that detecting it from real black holes light years away is practically impossible with our current technology.
So scientists had to get creative, and a team of physicists achieved the seemingly impossible. They literally made a black hole out of light, right in the laboratory. By manipulating light pulses in these precisely engineered optical fibers, they simulated an actual event horizon. This miniature light-based black hole allowed them to test Stephen Hawking's elusive radiation theory at the absolute tiniest scale in nature. They are literally proving cosmic theories on tabletops. It is mind-blowing.
And this total mastery over the tiniest scales of nature leads us directly into our final frontier for this explainer: cutting-edge computing.
Let's see how this builds our technological future. Classical computing relies on standard bits, ones and zeros, processing tasks in a straight linear line. But quantum computing uses qubits, which can exist in multiple states at once thanks to the weirdness of quantum physics. This doesn't just make them a little bit faster, it gives them exponential processing power. It allows them to solve hyper-complex problems in seconds, stuff like discovering new life-saving medicines or optimizing global climate models, things that would quite literally take classical supercomputers thousands of years to chew through.
And the craziest part? This isn't just theoretical anymore. IBM scientists recently pitted one of their quantum computers directly against an advanced classical supercomputer on a highly complex physical simulation. And the quantum system vastly outperformed the classical one, achieving a massive milestone and computational efficiency. This leads to a really bold statement that is currently shaking up the tech world. IBM scientists claim they've achieved quantum advantage, and they've actually dared others to prove them wrong. This dare is exactly how science progresses. They've firmly planted a flag, claiming quantum systems can now definitively solve useful problems better than classical ones, and they are openly inviting the entire global scientific community to scrutinize, test, and attempt to break their claim.
So what does this all mean for the next scientific frontier?
From a simple lawn sprinkler sitting in the yard, to 100-year-old chemistry dogmas, to creating black holes out of light and literally daring the world to beat a quantum computer, this explainer highlights one truly beautiful truth. Science is a continuous, thrilling detective story. Just when we think the textbooks are finalized, a new experiment blows the pages wide open. Which leaves us with this final provocative thought to consider today. As we continuously break the supposedly ironclad rules of classical physics, chemistry, and biology through modern experiments, what deeply established scientific fact that you learned in school will be the next to be entirely overturned? Thank you so much for joining me for this explainer, and as always, keep asking questions and stay curious.